The next presentation and the last one is going to be about the work that we've been doing with the new API in the particular context of Android, which is something that we started experimenting a while ago and is being evolving very positively. And the latest advancements basically are integration with the new API, updating to new versions, and bringing all the kind of good things that we've been discussing in the morning already, like Skia and many other things, into this. So Alex been working in WebKit also like forever, I guess, since Igalia started, was one of the first persons working in there. And yeah, I cannot do a talk myself. So Alex, just start when you have a moment.
Yeah, sorry, I was sharing the.
And by the way, yeah, need to get the microphone a bit closer.
Did it work?
Yeah, it works.
No, I was sharing the wrong.
I see there.
Did it work? Okay. No, it
Yeah,
worked.
try.
Okay. Yeah, no, I was sharing the wrong one. Sorry. Okay, shall I start?
Yeah.
Okay. So hello everyone and welcome. And this talk basically is kind of like a follow-up of a talk that we did last year, explaining in the last Hackfest what we did about WP Android. And where I'm going to try to explain is what we did in the last month, and how we moved WP Android to the new WP platform API. About me, well, as Mario is explaining, I'm Alex G in Slack. I usually add that because people is what we use in the WebKit channels, but maybe people here is not that interested in my nick there. But I'm being a long time WebKit contributor. Basically started with WebKit GTK, then WPE, then I spent last years adapting WebKit to small embedded devices, and I currently helping with this WP for Android effort. So first explaining what we did, what we explained last year. Last year, basically, you didn't attend the talk. Adrian gave a talk with this title, Jumping Over the Garden Wall, WP working on Android. And basically, he explained what we had at that point, which was this WP Android support using this all lib WP library, which is for us the all API. And it was building upstream already. We didn't have any downstream patches. We took it to the 248 stable release, supporting Android 15. Like basically, the idea was 3 parts. Cervera, which basically is the compilation, so that you understand later when I explain. It's the system that we use, kind of like the Yocto for the cross compilation for Android. And then we had like a WP backend for libwpe, which was like the old way that we created backends. And then we had a widget, the WP view widget, doing multiple things. And he explained basically last year that we wanted to move away from this classic libwp CAPI, which was a little bit verbose. He explained all the issues and very complex and difficult to maintain, and it was requiring for us a lot of engineering time to this new WP platform that also Carlos explained how it worked, all the classes that we had. And it was the default upstream already at that point, even when the release didn't happen for the moment. We are planning to have it in the next one, which will mean probably next July you're going to have the real announcement that it's the stable release. And it has multiple advantages. The fact that we are basically, for every person that is using WP with us, this has been the default in the last years. Just a reminder, we were explaining also how was the architecture, but basically the top is basically explaining that we had like a Java widget, WP view, and it included the widget and the engine handler, a lot of different things, a little bit convoluted in the class. And then it had the WP Android backend for libwp, and then the engine, basically. The engine is the same thing, basically. It's kind of like the WebKit environment, and then this small libwp abstraction that we used in the past for this. So going forward, the first step that we did was kind of like trying to create a new complete architecture, trying to think what would be like ideal for users that would like to test this, and for us in the future. And for us, this is kind of like experimental infrastructure that also for QA is something that we are considering. And what we did is basically define an architecture that fit with maybe a little bit ambitious. We had some discussions because we were trying to fit in every space that we thought that we could without that much investment, because in the end it's something internal. But as you can see from the application to the engine, we created layers that fit. The first one is what we call the convenience API layer, and this one, if you're not familiar with Android, basically what we did is copy exactly the Android API, which means that with that layer, we expect that people that wants to replace their embedded web view for Android, they can just use that one. You don't have to do anything else other than get the library, the Maven library, and then replace it. It's funny because it's called Android WebKit WebView for historical reasons. So now Android WebKit WebView has a WebKit backend. Then that is completely new. And then the second one is JKI proxy, which is basically a Java class and then a C++ class that basically doing the calls. We try to basically do this minimal, just proxies that are doing the calls internally. And as you can see, this one is more WebKit style, which means that an application trying to use the layer number 2 could use kind of like similar Java API, but it's more similar to what some WebKit developer could use. You can do it, but then you are not getting all the benefits of the first one, which has more integration in what Android and the NDKs. So this one is more for people that maybe they have a WebKit port in Linux or whatever, and then they want to port it to Android. But then you can use that one, and it's going to be easier for you. The third one is the new one, and this is kind of like the core thing of all the four, which is the WPEPlatform Android backend. And it's basically the same backend that in the past we had with libwp, but now it's with all the new APIs. And these are the classes that the engine is going to use to implement and connect to the different services that is required in Android. And then the layer 4 is the same thing, because basically that we had in the past is the upstream WP and the WP port inside WebKit. And the layer 0 is something that we basically didn't modify much, just some fixes, because it's kind of like the support code that we had for the executing inside Android, like Android Looper, which is what they use for the loops instead of glib, GNI with strap, event bridge, things like those. And now, when we define the architecture, we decided, okay, what's the plan then? And the plan was basically, okay, first, let's try to improve the foundation to make sure that basically low-hanging fruit around like tooling, server compilation, everything around that, the WebKit bumps. We wanted to also always use the unstable main release. And then after that, creating basically the implementation core, which, as I said, are the classes for WPEPlatform, porting them, and on top of that, the CAPI class and the convenience API layers. And when we have that, start porting all the small, those are the small applications that we have for testing. The mini browser is the driver that we have, a small application just doing some rendering. Media player is kind of a small demo that we have. Web driver so that we can run these tests. And then what it writes their test is basically some API tests that we use that are, in the end, you can see that they were useful to detect some issues. And then we started to implement some features to make sure that it's on par what we had, like they were interesting for us. And the final, we thought that let's remove the legacy API. So that was the plan. And basically we started implementing, and this is basically a more detailed explanation of what we did. First, with what I said about the server environment, our main goal was that anyone could easily test and deploy that, and you can do it. Actually, in order to do that, we decided that the right way to compile is using the WebKit SDK. So if you download the WebKit SDK and you download WP Android and run the instructions, it must work. And if it doesn't, then it's a problem for us and we can fix it. But in theory, it should be that simple. It's true that it's not that simple because It includes also like NDK install script. You have another script to basically create the cross-compile libraries that you need in a Bootstrap. So we work all around that. And then we had to enable this WPEPlatform API compilation, which was not enabled by default. We were compiling the whole thing, the WPE and all those stuff. So we needed like a small downstream patch that in the end made it upstream. And we started bumping new versions to main. The first one was the 251.93, and after that we progressed in the releases. And after the foundation was ready, we started implementing basically the backend. This took some time because even for us, some of the classes were not clearly, we didn't understand how to integrate that completely in Android because, yeah, we're not really very great experts in the Android platform, so we really needed to understand how to do it. And in the end, it was a really interesting exercise for us because we could verify that our abstractions work in Android too, and they were pretty similar to what we have for the WP platform GDK. It was pretty similar, and it was really interesting effort. And basically, as a small description, because we already explained this in one talk, but small details about these classes, which are the support for the engine, and here they're using like the Android implementation. You have the display one, which is basically getting the formats, discovering all the systems that you have for rendering, and the EGL init. And there is an interesting question here, is like, why are you using EGL init when you are using a hardware buffer? Saying it's basically just our API has this kind of like backup rendering system, but it's not used in the end in our case because we make sure that for at least the platforms that we are testing, we are all the time using a hardware buffer. Then we have the top level Android, which represents the main window basically, and then it basically handles all the life cycle of the main window. Like in Android, when you send the main window to the background, when it comes back, it can basically destroy all the buffers and all the resources. So you have to handle all the signals for Android, and then notify WebKit about that. Then you have the WP View Android. This one is basically handling the render loop, the sync fences, and the buffers, and the hardware buffers. And this we now have like a hardware buffer support inside WebKit, which means that WebKit is providing these buffers directly rendered from the web process, and then we are using them directly without EGL, passing it then to the Surface Flinger, I think, which is the compositor that Android is using. So there is no EGL in the middle to use that. Then we have the WP Screen Android that provides the information about the scale of the device, the refresh. Initially, we added it as a stub. Basically, it was like 60 frames per second, 1.0 scale, nothing else, the initial classes, and then we started progressing, adding more features to it. Then the input methods, again, this was initially just a stub, IME, text input, the keyboard handling and everything around that, which we have like in the font when you open it. And then the interesting one here that was not before is the screen sync of server Android. And in WebKit we have this concept of display link, which connects to the system to get the signal when the screen is going to be rendered in the screen. And in Android you have this A choreographer, which is the system that they use to basically send you the vsyncs. I think for Linux people it's more understandable, like it's basically the vsync but via that class. So we were getting all this information from the A choreographer, and then we use that to synchronize the rendering of the engine. And that was the main thing. And then after that, I mean, I had multiple discussions with Carlos, with Adrian. We didn't know how to do the top level at some point. We basically refactored the class multiple times. But after that, it was way more easy because we basically had just to add code that is kind of glue. Like the C API is basically just glue. That's basically sends the call. It's true that it's a little bit complex because it has some async calls and that makes it that you need to store a state of the code, like a closure for the functions, to make sure that you can, when you go back, you can call it. And then, but basically there are calls from Java to the GObject WP classes. And on top of that, the convenient API, that's really fun to do, because in the end, you are really checking the Android APIs and see that, oh, I can do that this way, this other way, and it's really fast. You can really create a lot of code for that. Once we had that, we ported the mini browser to this, and then they started adding features and testing it, which is basically, we still are using the mini browser to verify how it works. And updated the documentation with the architecture, now it works. And this is kind of like one of the reasons, now that we have this supported, that we can say that our API, the new API, is really powerful to be able to support these kind of systems without any different change. Okay, and then we had all the APIs, mini browser was port. Let's start porting the other applications, such as like the media player, which is like a small playback application. Not very good, don't try it, it's just for us testing. And when you try it, you can see that we have work to do regarding supporting different codecs, which is streamer in Android, which is something that we plan in the future, because it's really interesting to check how the codecs work with different proprietary hardware and what we can get from them. Then the web driver, which is the browser automatization, we basically have this application that is kind of like the driver of the whole testing sessions. We are using Selenium for implementing the tests that we have automated, and it's part of our continuous integration also for Android. For Android, it was not in the previous presentation, but we also have continuous integration, basically running the whole thing. Every time you upload a PR, it's trying this WebDriver test, the API test, and everything. And then the API test, which they prove useful, because here, for instance, they detected that there was an issue that it was real in how we were handling the focus of the web view. But in the end, like the result of all of this is that when we finished it, the whole repository was running on the new API. And then we thought that, like, okay, let's start adding like small features that will improve because they were kind of like low-hanging fruit, like the IME keyboard with clear inputs and verifying that everything works. Then the JavaScript dialogues with embedded overrides, so that people, like web pages that basically request to have a dialogue, we send a signal to the application, and mini browsers launch an Android dialogue, so they can basically answer questions. WebXR and VR, that Sergio helped with that. There was like some small patches to make it basically run, and it was very helpful, because now we are able to test this like in these pixel phones, and we are also testing this in these virtual reality devices. There is still work to do that Sergio needs to explain to me to get this immersive experience there, but I hope we can have the time to do it at some point. But this is something that I do basically nowadays. When I test in the phones, I also ask Sergio, please run the test also in the VR devices, because that way we make sure that we are evolving in the right direction. And then, because we are using the final versions, we are using Skia Compositor for this. We are enabling even the first display list since 2 weeks ago. And it was really useful, because now we test the first display list, and this showed that this backend is really useful for that. We were able to test all this in different proprietary drivers, Adreno, Mali, because the Pixel phones, like it's so easy to get phones with different proprietary drivers, and then you get a lot of feedback. For instance, this one, not having this one in some Adreno drivers was causing junk in the screen. A really weird junk. It's like pixels that were not right. So it was a crazy thing. And then talking to the Skia developers, we realized that, yeah, we probably should change the way that we are using. And then another super interesting thing is that we are improving a lot now, thanks to the force of running here. The scrolling, because we are able to see 120 frames per second and 90 frames per second all over the place, and it's providing so much feedback for us. It's really interesting because suddenly we have devices where we can run WebKit with very high demanding frames per second, which means that it's forcing us to reduce the dependency between the main loop and the scrolling thread, so that it's, I mean, our goal, hopefully like in the next weeks, maybe months, is that it's completely separated, and this is going to help a lot to define how to do it. Okay, and then the most satisfactory part, I have to say that it was like, I mean, it is like this. Like when you start removing legacy code, it's kind of like so great, because it was, the first part, it was so huge. We really removed a lot of different code, like legacy WP view, the WK API. And it's true that for an open source developer in Linux, where we are all the time very concerned about API, ABI compatibility, it's difficult to do that. But in this case, with these experimental projects, which are really great for us, we basically decided, no, we don't have the time to support the whole things. No one is using it for us, so let's remove the whole thing. And there we go with thousands of lines, and everything still was working, so it was also a good test. Still missing something, and I didn't realize soon enough, which is there is a small dependency. There is one code for Linux people. You know that when you launch a process, you use this fork system signal. That is not present in Android, at least with Android NDK. And you are forced to use a specific way to launch processes, which I didn't know about it. The NDK forces you to define some kind of service in a file, and then the file needs to, I don't know, some way to do it. And that's still living in libwp. Our plan is to move that to WebKit. Hopefully no one complains about it. It's the only part that it's kind of like, we're not sure if it fits there, but it's going to simplify the whole management that we do of the library, so probably that's what, at least I'm going to try to propose. Hopefully people accept it. And then while we were there removing things, we realized about different improvements that we could do. For instance, we had like a busy spinning loop, which was like using a lot of CPU, and it was not clear, and it was like a nasty usage of these pipes that we were doing in Android. So that took some time to find, but in the end we found it. And then we bumped, I mean, this is last week, we bumped to 253.3.1. This one does not exist in general. This is something that we are creating just for Android, which means that we are bumping specific unstable versions to Android, so that people can easily, without even compiling, just download WP by Android. Bootstrap is going to download that version, and then you can generate a file and install in your phones, and then you can basically test latest WebKit in your phone, which is, I think it can be super healthy for us, and getting like feedback about what you can do or what you cannot do, because even if you are developing in some other device, you could send a patch here and then test it. So. Okay, and what's next? Well, we have a lot of multiple ideas. This is just a small list of things that I would like to do myself, like send to people, because yeah, there are multiple things. So first is, as I said, remove this DWP dependency for good. Then we have the permissions API. We already have a patch for this with some implementation, even integrated with the NDK, which is super amazing how good it works in this. I mean, you have to understand that I'm used to GNOME Linux desktop. They provide very limited services and not very well integrated. And suddenly I use an API in Android for permissions, and you get like a huge banner, and then you click it, and then suddenly your web page is allowed to use your whole phone GPS service. And then you can run so many web pages with testing and APIs that in Linux is way more limited. We don't have that many things. Or for cameras, for geolocation, for microphones, it's really interesting. And then with Screenshots API, we already have a patch for that. It's a matter of integrating, and the developer is not sending it to me. I'm forcing at some point. Pre-edit and composition text, this is also so interesting because Android has a really nice support for the on-screen keyboard, and they have these options to basically write kanji or these languages where you add multiple characters and then they go to one. We can add support for that in our UI, which is pretty easy. So hopefully we add it also too. And then media capture also. Then small details like this SSL error callback flow. For the moment, we're accepting. This is the callback flow where you enter a site and the site does not have a proper certificate, and you have to show the user the certificate is wrong, and you have to make a decision about that. We need to implement that callback. As I said, improve scrolling. I really hope, like in the next weeks, we are really improving that. It's already quite good, but there are things that we realize that, for instance, now that iOS has, macOS does not, and we were kind of like forgetting about those because it's kind of like, yeah, it works 60 frames per second, it kind of works, and macOS is not using it, let's not use it. But then suddenly, when you use the device, it's kind of, oh, this is so interesting, because we can basically avoid a lot of different calls. And in embedded devices, it's going to show, because you are avoiding also performance, because you are avoiding sending signals or like running different scenarios where in laptops probably does not make much sense. And then regarding CI and integration and quality, we want to make the Selenium testing work because it's to harden the development is kind of like working, but some testing are not working for a long time already. So this needs to be like updated, and then we plan to add more testing for this. And then we want also to add a post-commit bot in WebKit. Because as you can imagine, we still don't have a post-commit bot in WebKit, which means that developers doing changes can easily break it, and we go and fix after the bump, which is what we do usually. We're used to that because we do it with multiple customers, with downstream patches. This is basically what we do. We basically bump and then verify the situation. And then to end, just some numbers. Basically, we merge 45 PRs, 28 in the Android server, which is basically the final thing. We moved from 250.4 to the latest. We removed the legacy API, and those are like the two repositories that you can check to see the work. And if you want to run WebKit, the WebKit that you run in whatever device that you're running, you just go there, compile it, and install it in your Android device, and you are going to be good to them. Thanks to Oligada teams working around this, because in the end this is like a effort of a lot of different people, and that's all. Questions? That's basically a screen record of, because the tooling is also good for development in Android. That's all.
Yep. Thank you. Perfect timing.
I know.
I mean, I look surprised.
I have a lot of practice.
I look surprised because I am surprised. But yes.
Okay.
Any comments or questions? Maybe from other people also working on Android. Any comment? Any extra comment that you want to make? I'm
So
looking at anyone.
just one thing. If you want to test it, I have a version here in a Pixel phone. So if you want to play with it, don't be bad because it's experimental.
No comments or questions? Okay, so I guess then we are perfectly on time. Thank you, Alex.